Assignment 4, but I'm not sure if it's showing up yet. We go here to assignments. I don't have it on Brightspace yet. Yeah, it's right here. They use our library. So I kind of reduced this one a little bit compared to what we did last term. I'll make it more specific, and then I'm gonna, over the break, probably this weekend, I'm gonna push Lab 1, which is gonna be more comprehensive, a little bit more stuff. You will be using the display for Lab 1. I'm gonna add enough information to see if you can figure it out and get some of the other UART working after you actually complete your library, which I hope at this point is very close. Okay? We just need to go, but before we jump into that, there's only a couple of things I want to talk about today, so hopefully it doesn't take longer than half an hour. But let's go over attendance first.
You sure you put assignment for?
Yeah, it's on the site. I just saw it. Yeah, but not on Brightspace yet. Yeah, I know. I was just doing some tweaks earlier. So, but the link is there. Yeah. I'll put it on Brightspace as soon as possible. It's just been such a busy day for me today. Like every day, but today in particular. Okay. So let's go over attendance quickly. I'm afraid not here. I'm surprised. Chintan, never seen. Carl here. Winston's here. Wolfo is here. Omar, not here. Arshdeep is here. Steven's here. Never seen these other guys either. Joe John here. Steve Ranchit. Rex is here. Hill, never seen. Jacine is here. Kritika. Here. Rosine is here. Yeah. Jin Yuan. Yeah. Joe is here. Yeah. Okay. If you're here, most likely you will succeed. If you're not here, you're risking it. All right. Let's bring up desktop. Let me see what do I have for demos. Let me just bring up my entire repo. Why do I have so many libraries here? I haven't pushed. Maybe I should push. Yeah, I guess it doesn't hurt to push this one. Because then I'm going to have a mess when I want it, so I better push. So last class we discussed the states for the buttons, right? And how to send a message. That will be more applicable for Lab 1. I thought it would be for assignment 4, but since I split it, I guess this will be left for Lab 1, but it's already covered. So when I release Lab 1, you will be able to do it. So far we've been sending a message, right? We've been also receiving characters or bytes, and it's the same thing, right? And then we're sending it back to the terminal so far, right? Now the part that we haven't done yet is actually receiving an entire message, okay? And that's what we're gonna focus on today. The problem is I just have the demo completed, so I don't want to, let me see. I'm gonna bring it up here, and what I'm gonna do is just move the whole thing to here. And obviously compilers is starting to be annoying, so I'm gonna dismiss it for a while. And I have it on VS Code, but I should probably open Sega, right? Let's better background. Okay, so I copied this demo from the previous one, so it's exactly the same in terms of the button press, button release, whatever. I just added these parts. I don't know if it was in the other demo, to be honest. And I'm using, of course, the UARTs for everything, initializing it at this point. And I haven't been using any other baud rate for now, but any baud rate should work. And I'm checking here if I'm receiving a character. Remember, when we receive a character, this should return a 1, right? Because it's treated as a Boolean, and whatever I receive gets stored by reference in this variable, Rx data. All right? All right, so if this is to receive one character, right? So how can I receive a message? What is the first thing I need to be able to receive a message?
Something to repeat.
Yeah, well, the characters are being read, so the characters are being read one by one, right? So if I want to receive an entire message, what do I need? Huh?
Array.
A what?
Array.
An array of characters. Excellent. Yeah, yeah. Because if I have only a variable that can store only one character, I'm gonna lose the next. It's gonna be overridden, right? So I need an array. Okay, that array was declared already, and I called it Rx buffer. Okay. Of what size? Well, I defined this constant 64. You could choose the size depending on the expected, message, right? I just don't say 30,000 because the RAM memory for this micro is 32K. So if you say 30,000, you will be using more than 90% of the RAM memory, which will be really bad. Okay. So we have this array. So if I receive a character, at this point, if I'm inside the if, is because I already received the character, right? Because that returns true if we receive the character. So the character, it's already in Rx data. Okay? And I did define also this Rx buffer index, right? That is going to be for indexing my array. Okay? It's initially going to be initialized at 0, right? As well as my array, please pay attention here that it's being initialized as an empty array, so it's going to populate all zeros. Because if you don't initialize the array, it's not guaranteed that it's going to have only zeros. It could have some random characters. So if I store what I received in the array, what do I need to do next? So I can receive the next character in the next iteration.
Rx buffer index plus.
Yeah, it needs to be incremented, right? Because otherwise it will overwrite the same position. So this needs to go plus plus, right? Okay, but if I want to do it, this will be the C# programmer version of it. The C programmer version will be this one. Right? Well, you can also, to be fair, you can also do this in C#. It's just that it's not common to see it, right? Yeah, and that will be a post increment. So it's going to use Rx buffer index first, and then it's going to post increment it after it's being used. Okay, so it's going to add the character to the buffer and then increment the index. Is that clear or not?
Yes.
Yeah, so I'm dumping the characters into the array and incrementing one by one. What else can I do? Well, let's give it a try. Why not? I'm going to open a term, and it should be by default connected at 9600. So if I press the button, button press, button release, it doesn't work. Is that part being used still? Yeah. Oh, am I pressing the wrong button? Maybe. Oh yeah. Okay, there we go. That part is working. Okay. What? Okay, I'm gonna clear the buffer. And I'm going to send a message, but I'm going to enable the local echo so I can see what I'm sending, because I'm not echoing the character anymore. I'm just putting the characters into the buffer, right? So I'm gonna say serial ports, not serial ports, sorry. Terminal, enable the local echo. So I'm gonna say, hello, CMPE 1250, and nothing else. I'm not gonna press enter. So I'm gonna go here, and this is what you when you know how to use the system, right? You're gonna put a breakpoint here, and you're gonna look at your RX buffer. If you don't have it, you can add it here, right? You can type the expression, and it says hello CMP 1250. Okay, and the ASCII codes are here. Okay. So if I type now enter, I'm gonna resume this. If I now type enter, and I check this buffer again, like let's say I put a breakpoint here, now it has a \r at the end, okay? Because that's the enter character, it's a \r, and it happens to be a D in hex or a 13 in decimal. That is the ASCII code for the carriage return. Now, in any programming console application, like what we remember from our 1300, typically the enter is when you enter something, right? When you send the data into the program. So why don't we try this enter key as the end of whatever we're receiving, right? So then we're gonna change this program in such a way that we do this. We're going to say if the character that we received equals what? \r. Be aware that you could put a 13 there, you could put a 0xd, whatever it's equivalent, because at the end of the day, that's an ASCII code, right? But I'm just going to use the \r to make it more self-explanatory. So then I'm going to say end of message or something like that. Normally I call this end of the packet. And I'm going to do something. Nothing yet, but otherwise, I just keep adding to the buffer. Okay? So now, since I'm able to recognize if it's a carriage return, you press an enter, I'm going to consider that as the end of the message, and I'm going to do something about it. Okay? So what I'm going to do about it is just this. And for this, I'm going to use my cheat sheet to make this faster. I'm just going to transmit back and say you sent, and then transmit back the same RX buffer, and then add another line to it at the end. Why would this work? Because your TX string prints until it's 0, right? So it won't print the 64 bytes, it will print just the ones that have values different than 0, right? So basically it will print the string. And let's give it a try now. Are we following up to this point? So we're buffering what we're receiving. Huh?
Somewhat, yeah.
Yeah? Well, raise your hand if something is not clear. Hello, CMPE 1250. Enter. You sent. Oh, well, it didn't. I kind of. Why did it go to the same line? Now that's bothering me. Let me add a new line and a carriage return at the beginning, because I really didn't like that. Let's try again. Clear buffer. Hello, CMPE. This thing, the problem with this is, yeah, whatever I press, it's not that I can go back, it's just gonna send the characters. Whatever you press here gets sent. It's not like a regular terminal in Linux or Windows. What did I do? Yeah, so we can now really correct, so we have to be careful. Hello, CMPE 1250. You sent hello, CMPE 1250.
There you go.
Hello, everyone. Well, yeah, I'm not going to be able to go back there. I don't think so. Hello, CMPE 1250. Hello, everyone.
So you'd have to add in a function to clear.
Hello. Yeah. Everyone
It's
sees
just
what's
adding
happening,
to
right?
the character array.
Yeah. So I'm effectively adding things to the buffer, but I'm not clearing it. Moreover, well, I'm going to say here, when should I clear the buffer? Whenever this is processed, right? So I'm going to add a comment here, clear buffer. And we're going to deal with it in just a moment. But one thing that we are definitely going to have to do here is set the Rx buffer index back to 0, right? For sure, that is for sure. So I'm going to give you that one for free because you're going to research the other part, right? Otherwise, it's not fun. So, yeah, so if the packet is complete, I'm going to do this. Otherwise, I add to the buffer. But what happens if I just keep adding characters and I never press enter and I send more than 64 characters? My program is going to crash, right? So I should probably have some check here. So I'm going to say if rf index is less than Rx buffer size, only then add the character. Only then add it to the buffer. Otherwise, the buffer is full. Okay. And I'm going to print here, and forgive me for just copy pasting, but I want to make this quicker. Else, I'm going to send buffer is full. Okay? Now, for the sake of making this quicker, I'm going to change it to 32. Sorry, for a moment. And I'm going to try to overrun it very quickly. See? Buffer is full. I cannot really send anything more. So now my program is bulletproof, right? Because it won't add to the buffer anymore. If I didn't have that, I would have made it crash right away. Because the index would have gone beyond the size of the array. See, those kind of things, we need to be careful. So I'm going to put this back to 64. Now the question is, how do I clear the buffer? And you're not allowed to say anything. Sorry. How do I clear the buffer?
We might have talked about it in the first week.
No, I don't think we did. No. We haven't talked about this because we weren't buffering things yet.
No, but it should be the same
But
concept as
let's
clearing.
say if you didn't know anything at this point, you just know what I've talked in this class and 1300. How would you clear the buffer? How do you make sure it's all zeros again? Can you do this? Can you do something like, I don't know, something like this? No, right?
You just have a
I
function
wish there was something like that.
that writes all zeros.
Yeah. I effectively need to write zeros where the thing is, and how can I do that?
With a for loop.
With a for loop. Now the question is, do we want to do that? You got no problem doing it? I do have a problem with doing that because it seems like tedious to me having to do that. I would like to do this in one line, and I'll tell you something. It is possible to do it in one line. Now, a few days back, I don't know how many classes ago, I asked you to research how could you copy from one array to another. So, did anybody research that?
In
I know you
C?
did. Hmm?
In C?
Yeah. No? Or now you have another task to add to your pile during reading break. Okay. Remember, everything I tell you to do, even if it's not an official assignment, is because you gotta kind of research that on your own, okay? Which is why, at this point, for the remaining of the class, which is about 30 minutes, I'm gonna ask you to research how could you clear the buffer in one line and make it work, okay? Based on this demo. So I'm gonna push it now. Now I'm gonna give you a hint. The answer is in the string library, string.h. And the answer to the previous question that nobody did, it's also in the string library. So it looks like we need to research the string library. Or no, you're going to look at the string library. It may look confusing, but that's where you can actually look online or even ask the AI, how does the function work? Like whatever function that you're attempting to use, okay? And yeah, any questions? So once you are able to do that, call me over and I'll check your implementation and show me that it works actually. But this is assuming that you already have these functions coded. That's the only problem.
Mm-hmm.
Who's still working on the library? What's that? Oh, still. Okay. Come on. You shouldn't be in that situation like this. Well.